All right, so the counting principle starts off talking about an experiment. An experiment is an activity with an observable outcome. So an example of that, easy example of that is flipping a coin. Sample space, all possible outcomes of an experiment. So when it comes to flipping a coin, heads and tails will be all of your possible outcomes. Your sample space is usually denoted by S. In other words, S usually represents your sample space. An event, any collection of outcomes from the sample space. So if you want to know the probability of landing tails, then tails would be your event. And that's usually denoted by any capital letter. Of course, you wouldn't want to use S, because S, is used by your sample space, but any other letter you could use, to denote your event. All right. All right, first exercise. One number is chosen from the sample space, and they give us 1 through 10. Sample space is 1 through 10. List the elements in the following events. First event is that the number is even.
Can you go up a little bit, please?
Yeah, right here?
Thank you.
Yeah, no problem. All right, yes. I'll wait a second, make sure everybody's with us before we keep going.
What are the title of these notes called, of this topic of the lesson?
I forgot. Let me go back up. Oh, the counting principle. The counting principle. Counting principle. Yeah, counting principle. All right, so list the elements in the following events. So if you're talking about the numbers even, so you would look at your sample space and look at all of the even numbers. And that's what we have right here, 2, 4, 6, 8, 10. So each number is considered an element. And you want to write all of the even numbers that are in your sample space. It would be 2, 4, 6, 8, 10. Next one, the number is divisible by 5. Once again, you would go to your sample space and find all of the numbers divisible by 5. In this case, it would just be 5 and 10. All right, then the last one, number is prime. And a prime number is a number that's only divisible by 1 in itself. And once again, we're only talking about the numbers that are in the sample space. So it'd be 2, 3, 5, and 7. All right, questions on that?
What did you say the prime numbers were again?
Numbers that are only divisible by 1 in itself. So in other words, when I look at 4, I can divide that by 2. If I look at 6, I can divide that by 2 or 3. 8 can be divided by 2 or 4. You know, you can divide it by something else. But when I look at 2, nothing can divide into 2 but 2. You know, same thing with 3, 5, and 7. The only thing can divide into 7 is 1 in itself. All right. Questions on that before we go to the next exercise? All right, here we have 2-digit numbers are formed from the digits 1, 3, and 8. Somebody say something to me? Oh. 2-digit numbers are formed from the digits 1, 3, and 8. Find the sample space and determine the number of elements in the sample space. So we want to create 2-digit numbers with the numbers 1, 3, and 8. The best way to do this is by creating a chart. That's what we have right here. When I did 1, 3, and 8 on top row, 1, 3, 8 on left column, and create all the numbers with those 3 numbers. So you got 1, 1, 1, 3, 1, 8, 3, 1, 3, 3, 3, 8, 8, 1, 8, 3, and 8, 8. So creating a systematic chart will help, will ensure that you don't leave out any combination. And then you see we have 9 elements in the sample space, or 9 separate numbers. When we look at these, have 9 separate numbers in the sample space. Any questions? All right, scroll up. Is everybody okay? All right, so the next one, a true-false test consists of 10 questions. Draw a tree diagram to show the number of ways to answer the first 3 questions. So notice it tells us to draw a tree diagram, and we're only interested in the first 3 questions. So even though it's a 10-question test, we're only interested in the first 3 questions. And we're looking at doing true or false as a true or false test. All right, so first we're looking at if we were to answer true for the first question. From there, we have 2 options, true or false. And then from each one of those options, we have the option of true or false. Right. Then you explore answering the first question being false. From there, true or false is your options, or are your options. Then from each one of those, true or false will be your options. Excuse me, I had to sneeze. But then after that, you know, this is just a list of, you know, your options total. So you got true, 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 false, true, and so on. And that's all they ask of you. Just want us to draw that tree and explore the options of your first 3 questions. Any questions? Any questions?
I'm drawing the diagram real quick.
You're fine.
Can you re-explain how the diagram works?
You start off with true. From true, because you're talking about answering the first three questions. First question, third question. First, second, and third question. So you start off answering what if you answer the first question as true. From there, you have the options of going true and false, true or false. If you decide to go true, then from there, you have the option of doing true or false. But if you decide to go false, from there, you have the option of doing true or false. There's always, you're just going to always do true or false when you go to the next question because it's a true or false test. So each time that you answer a question, the next row or next column would be true or false. Say,
Excuse me. I'm sorry, Professor.
huh?
I just want to know what questions were going to be asked
What you mean?
for the true and false.
You going too deep. You too deep. You too deep for this class right here. We ain't even talking about that.
And I might be too dumb, but I sure ain't too deep.
So no, we just said in general. We're not even talking about what the questions are.
Oh, okay.
Yeah, you have a true false test.
Oh, okay.
Yeah, and what are the possible ways that you can answer the true false test? The first three questions.
Okay.
Yeah, so they're not in this type of scenario. They're not giving you what those questions are. What would prompt you to go true, or what would prompt you to go false? That's where you're getting into. They're just saying, in general, what are your, what combinations will be produced, and that's what will happen. Yeah.
Okay. All right. Thank you.
Not a problem. So, yep. Any more questions on this? Because, like I said, they're not asking you what prompted the person or what will prompt you to go true or false. They're just saying, what are your possible ways of answering the first three questions? So here you could answer true, true, true. You could answer true, true, false. You can answer true, false, true, true, false, false, and then so on. So those are just the 8 different ways that you could answer the first 3 questions.
Okay. So it's really no right or wrong answer?
Well, no. Well, it's just that these are your 8 combinations. So it's really, did you find out all 8 combinations or not? Pretty much. And if you do this tree, then you don't have a choice but to get these 8 combinations. You know what I mean?
Okay.
Yeah. All right. So so if you talk about right or wrong, it's not like if you put true, true, true versus false, 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 that that's a right or wrong answer. No, it's just that you had to come up with these 8 combinations right here. Yeah. Just have to take your time, sir. Just take your time and just, like I said, just branch them out. Just branch them out each time. You'll be fine. So let's look at the next thing, the fundamental counting principle. I think this is a little easier. It says if you can choose one item from M items and one item from N items, then the total number of 2 item choices is just M times N. All you're gonna do is multiply those 2 numbers together. All right, looking at the first exercise, if you have 30 shirts, 20 pairs of jeans, and 10 pairs of shoes, how many different outfits could you create? So we're going into this with the assumption that you're only going to wear one of those shirts, one of those pair of jeans, and one pair of shoes. Sometimes people double up on shirts or whatever, but we're just talking about one shirt, one pair of jeans, and one pair of shoes. 30, 10, and 20. You just multiply those together, and that will give you 6,000 outfits. And that's all it's saying is that if you can choose one out of each category, multiply the total number of options that you have in each category, and that would be the number of items that you can create. So in this case, the number of outfits that you can create. So next time you say you don't have anything to wear, you know, it might be an outfit out there that you haven't tried yet. All right, any questions?
Uh,
So is that an all, or I guess we're good? All right. So next one, in horse racing, betting on a trifecta refers to choosing the exact order of the first three horses to cross the finish line. If there are 8 horses in a race, how many trifectas are possible, assuming there are no ties? So I'll give you a chance to write that down. All right, so we erase this. So there are 8 horses, and we want to look at the first 3 horses to cross the finish line, first, second, and third place. So I set up my boxes here, first place, second place, third place. And we're going to put the number of choices we have for each place. So what do I mean by that? I know we have, we have 8 horses altogether. As far as the number of options or the number of horses that could cross first place, it would be 8. All right. Now, after that one horse crosses, there are 7 horses left that could cross at second place. Then after that horse crosses, there will be 6 horses left that could cross at third place. So that's how you would set
excuse
that
me.
up.
My computer went off, and are you able to go back to the fundamental counting principle, and underneath that definition is the other stuff that I didn't get to yet?
So we all have to suffer because
I
I'm just messing.
mean,
I'm just
it was an
messing.
accident. I didn't mean to. My computer just shut off.
It's all good. Let me
Okay.
let them go ahead and copy this real quick since we're done with it, and
Yeah,
then
yeah.
I'll double back.
And then I have to copy this too next
Look,
in order.
you need to take some screenshots. No, I'm just messing. It's all good.
Yeah. I'll take some screenshots next time. I'll
Uh-huh.
take pictures next time.
So finishing this all just to make sure we're good to go. So for each box, once again, I set up for each place that we have. For each place, I set up a box. And in each box, I wrote down the number of choices I have. So once again, we had eight horses altogether. So for first place, there were 8 horses that could have crossed first place. Now, after that horse crosses second place, that means for second place, we only have 7 horses left. After that horse crosses second place, for third place, we only have 6 horses left. And once you do that, that's where the 876 comes from. And once you do that, multiply them together, that gives you 336. 336 possible trifectas. All right. Any questions on that before we double back? We have a classmate that's being a problem today. So we're gonna go ahead and do that for her. Let's see, everybody good? Okay, so let's see. Did you need the actual fundamental accounting principle or just the problem under it?
I just need the problem in purple.
All right. Matter of fact,
Yeah.
let's do it like this. That's too small.
Thank you very much.
Not a problem. Let me know when you finish.
Okay, so now I'm on the red part now. I'm on the red.
All right. Cool. So now we say, Ray, you talk at the top, right? At the top, 30, 20, 10.
I'm at the green now, the green part, multiply.
All right, cool. All right, y'all. So let's look at this next one down here. From the letters A, B, C, D, and E. Somebody said something in the chat. If you bounce the trifecta, doesn't mean 5, 12. Well, no, with the trifecta though, we're going to do 8, 7, 6 because, you know, once the horse crosses first place, it can't come back and run again. Remember, we had 8 horses all together. So once it crossed first place, it's done with its race. So now what's left is 7. So now you have 7 horses that could possibly come in second place. Once that horse come off second place, in third place, we only have 6 horses left that could come in third place. So that's why it would be 8, 7, 6 and not 8, 8, 8. All right. That makes sense? For the person in chat. Okay, cool. All right. So we're looking at the bottom one down here for the letters A, B, C, D, and E. Let me erase some of this stuff out of here. How many 4-letter groups can be formed if a letter can be used more than once? So I'm going to erase this a little bit so we can walk through it. All right. So this kind of leans towards what one of your classmates just asked with the horses and why wasn't it 888 versus 876. So when we look at this first example, dealing with these letters, we have a 4-letter group. So we want 4 letters. That's why I have 4 boxes right there. And then it says how many 4-letter groups can be formed if a letter can be used more than once. So now if I have 5 letters all together, then that means if I can use it more than once, then I can put a 5 in each one of these boxes. So that's why that's going to be 5, 5, 5. So going back to the horses, that's why we didn't have it as 888, because those horses couldn't be used more than once. Once they cross the finish line, then they're done racing. But here we have letters that can be used more than once. So that's why we have 5, 5, 5. We have 5 letters. You can use all 5 of them. In other words, I could have I could have A, B, C. Like, if it can be repeated, then that means you would keep using that number of 5. And so multiplying those together, they give us 625. Okay. That was Regine. Can I scroll up now? We good?
Yeah, now I'm on from the letter A, B, C, D. Now I'm on that part.
Okay, you good, yeah. All right.
Yeah.
Cool. Thank you. So, and then B, it says each letter can be used exactly once. And that pulls us into what we did last with the horses. That's why we have 5, 4, 3, 2. Because if I have 5 letters and I use one, when I go to the next box, I can't use the one I just used. So now I have 4 letters to choose from. Then go to the next box, 3 letters to choose from. Last box would be 2 letters, and then multiply those together. 5, 4, 3, 2 will give us 120 different ways of doing that. All right. Make sure we're okay with that.
So, Professor,
Mm-hmm.
the question is being asked with letters. We use numbers.
Say that one more time. You said the question is being asked what? You kind of went out, went in.
Yeah, like I'm sorry. Like if the question's being asked, if it's using letters like A, B, C, D, we use numbers to answer the question?
Yeah, because these numbers represent your options. So in other words, how many options did I have? I had 5 letters to choose from. You see what I mean? I had 5 letters, A, B, C, D, and E. And so that's what that number 5 represent. It represent the number of options that I had. So if I
Okay.
had,
That makes sense.
yeah, if I
That
had
makes
Yeah.
1, 2, 3, 4, 5, or let me say this, 1, 2, 3, 4 triangle, right? The numbers I would use here would still be 5 because I
Mm,
have 5 options to choose from.
okay.
All right. So yeah, so
All right.
that's what it's about. Yeah, we're counting the options that we have, and that's what we'll use to calculate. Yeah. All right.
Oh, never mind.
All right. Anything else? Anybody else?
And for the one on the bottom for letter B,
Mm-hmm.
you said that 5 times 4 times 3 times 2. So what do we do about that then? What's the difference between A and the difference between B then?
Okay. A, it says that you can use your letters more than once. So each box, each time I choose a letter, I have 5 letters to choose from because I can repeat using the A or repeat using the B. Here, you only can use it once. So once I use a letter, that's no longer an option. So remember, these numbers represent how many options I have in each box. So if I have 5 letters, once I use a letter, the next time I go to choose, I only have 4 letters left. And then next time I choose, I only have 3.
Oh, right. I remember what you said.
All right.
You can
So we
only use
good.
it once, but the other
Right.
one you can use more than once. Okay.
Yeah. Uh-huh. All right.
I'm
Anybody
all
else?
caught up. Yay. Hey. Oh,
All right. Anybody else before we go to at least start 12-2? Pretty good. And as always, when you try this stuff out, if you guys get stuck on anything, make sure you ask, bring it to class or whatever, and we'll knock this stuff out. Try to make sure you have clarity. Last class, we finished 12-2. We'll see. If we don't, no harm, no foul. See what happens. So 12.2, permutations and combinations. First thing we're looking at are factorials. So the exclamation point in mathematics represents factorial. And so here n just represents any number. So you start with the number that they give you and you count down by 1 all the way to 1. So what I mean by that is if I have 100 factorial, that's going to be 100 times 99 times 98 times 97 all the way down to 1. So that's what your factorial means. 1 factorial equals 1. 0 factorial also equals 1. And there is a proof for that, but I'm pretty sure y'all don't care to see it. But just let you know, those are 2 things that work out for us. 0 factorial does equal 1. And here's just a mini example of how the factorial work, outside of using that 100 factorial. If I have 4 factorial and I want to evaluate it, that's 4 times 3 times 2 times 1, which is 24. So you take that number that they give you, go down by ones all the way to 1, and multiply those numbers together.
I don't see the purple.
You want to see the purple?
The purple. Okay.
Do you have something that's covering the bottom of your screen? Or is it my stuff?
Yeah, it's
Oh.
like a part of like the Zoom. I'm not able to take it off.
Oh, okay. Gotcha.
It has like the participants, share screen chat, and more on it, and it's covering all of it.
Oh, can't you, hold on, can't you move that to the side? Anyway, you ain't got to worry about it. Never mind. I was about to
Let me
play with my
see.
stuff. Let me erase some of this stuff. Let me look at this. All right. So let's look at evaluating. I'm going to show you the long way. I'm going to show you the short way of dealing with the evaluating of factorials. We have 8 factorial over 5 factorial. So first way is the long way. You span this out. Notice 8 factorial is 8 times 7, 6, 5, 4, 3, 2, 1. 5 factorial 5, 4, 3, 2, 1. So that's considered a long way because let's say if you go back to 100 factorial, what you don't want to have to do is to write out 100 times 99, 96, 97, 96, all the way down or whatever. So, but what we recognize when we look at this is that if you go back to how your fractions work, any numbers that are in common over the top and bottom will cancel out. So 5, 4, 3, 2, 1 cancels out with 5, 4, 3, 2, 1. And that leaves us with just 8 times 7 times 6. All right. 8 times 7 times 6 is 336. That would be your answer. All right. Any problems? Any problems? So the short way of dealing with this is that we recognize that this right here is 5 factorial, and this is 5 factorial. So if I want to write it the short way, I could have just taken that 8 down to 5, recognizing that 5 factorial is a part of the 8 factorial, and cancel out that 5 factorial, leaving me with just the 876, and still get the 336. All right. So the same thing happens with 100 factorial over 98 factorial. We don't want to have to write out 100 all the way down to 1. But we recognize that we have 98 factorial in our denominator. So we just go down to the 98 factorial and recognize that they'll cancel out for us. And whether you write all the stuff out or not, it's up to you. But this is how you would process, the situation. And so 100 times 99 is 9,900. And that's it. All right. Questions? Just trying to raise this up just in case somebody can't see at the bottom. Everybody done with 8 over 5? Okay. So next one, we have 5 factorial minus 3 factorial. What you cannot do is do 5 minus 3 and then have 2 factorial. All right. These are two separate applications. 5 factorial is 5, 4, 3, 2, 1. 3 factorial is 3, 2, 1. So you go ahead and expand those out and then multiply them out. 5, 4, 3, 2, 1 is 120. 3, 2, 1 is 6. Then 120 minus 6 is your 114.
So how come there's no cancel of 3, 2, 1?
Well, you only do that when you're dividing. So if you had 5
Okay.
factorial over 3 factorial, then you would do that. Good question. Good question.
Thank you.
Not a problem. Anybody else before we go to the next thing? Make sure we're good. All right, everybody good before we look at permutations? All right, so permutations, an arrangement of items in which order matters. And that's going to be this distinction of when you use permutations versus combinations. You'll see when we get to combinations, the order does not matter. But permutation, the order matters. And we're talking about taking a permutation of n things taken r at a time. So what do we mean by that? So in other words, if I have a class of 30 students and we're going to go on a field trip and I only can take 5 people. So how many different ways can I take 30 students 5 at a time? Or how many different ways can I choose 5 out of that 30? And so this is what we're talking about here. N is always going to be the larger number. And then, you know, like I said, 5 at a time, which would be R. This is the formula. I'm going to show you how to use it, but I'm not holding you responsible for knowing exactly how to calculate with the formula. But what you need to do is make sure you know how to use your calculator, or you know how to use a website that can do it for you. You can easily Google permutation calculator and that'll pop up. Or if you have a scientific calculator, you know, this, you know, should be in there, whether it's NPR or if it has box P, you can write it like that, box P box, where you can put in the value for N and R, or whatever way they have it set up, depending on your calculator. So feel free.
Are we going to be able to use said calculator on tests?
Yeah, I wouldn't set you up like that. That'll be dirt.
I'm just saying, you said to Google it, so I was making sure, like, Google a calculator, but how can you, like, check if we're not Googling everything else, I guess?
Well, you know, in the climate that we're in, I'm not really going to be like, you know, like that. I mean, because then I would have to make sure you guys download like a, what is it called? Not an internet blocker, but I forgot the name. But the thing that prevents you from going to other websites and stuff like that.
Browser.
And I'm
the lockdown browser.
There you go, lockdown browser. Thank you, sir.
Yes, sir.
Lockdown browser. And so, I mean, I'm not even gonna get into it like that. If it was that serious, then I don't know. I think we need to have a little bit of a idea that, you know, cognizance of that fact that, you know, we're dealing with a situation that's not the norm. So I don't really get onto it. I know there are some professors out there though that's really getting it. Like they're really on you guys about not.
I have a couple of them.
Yeah,
I appreciate you, Professor. I appreciate you.
Not a problem, not a problem. But it's real out here, man. For some people, man, I know one instructor. I won't say one, a few instructors. They're making people use multiple cameras. So you have to have a zoom on you. Then you have to take either your smartphone or some other device to be on your hands, and they're using lockdown browser. So it's like it's real crazy for some people, man. So it's all good. I try to be as lax as possible. Yeah, that's all. Yeah, I do want to see you guys be great and get out of here with your ABC or whatever it is you're trying to get and roll on to something greater, man. So yes, you know, not to get on that soapbox. I can be talking about instructors all day. I try not to, and my colleagues. So not a problem. And plus, this is gonna be on the internet now, right? Because I done recorded it. So but this is the formula right here. And you will, whatever it is that you use, make sure you're efficient at it so that you can use it on the test like your classmate mentioned, and make sure it's reliable. So let's get into how we would use it. A university tennis team consists of 6 players who are ranked 1 through 6. So notice we have a ranking. That means that the order matters. That's how you know you're going to be using the permutation instead of combination. If a coach has up to 10 players from which to choose, how many different ranked teams can the coach select? So I'm magnify a little bit. And let's pull up. So we have 10 players all together, and we want to choose 6 out of the 10. So right here we see that I have it set up that N is 10, R is 6. Remember, N is always going to be the greater number. Did I say R? I meant N if I said R by mistake. N is always going to be the greater number. N is always going to be the greater number. So N is equal to 10. R is our 6. Put it in the formula. N factorial over 10 minus R factorial. I said N, 10 factorial over 10 minus 6 factorial. 10 minus 6, do what's in the parentheses. That'll give you 4. So that's 10 factorial over 4 factorial. And go ahead and cancel out your 4s or your 4 factorials, which would be 10, 9, 8, 7, 6, 5. Multiplying together 151,200 different ways to create this team of 6 out of those 10 players. Yep. Once again, this process right here is not really emphasized. If you want to do it by hand, feel free, but you do want to make sure you at least check it by calculator. You know, when you do stuff by hand, you know, give yourself a chance to make an error. So at least know how to do it in your calculator so that you can be good to go. All right. Problems with that? All right, can we scroll up? Everybody good?
Wait, can you go back?
All right, not a problem.
This red part. Okay.
Yeah, you good. All right, so the next one, in 2015, we have 18 horses that were entered into the Kentucky Derby. How many different?
Excuse me.
Yes.
I have a question. After 10 over 41, is that 10 times 9? Is that a 9?
No, that's 10
10
over
times.
4 factorial.
Okay, and then
Yeah.
after that is 10 times 9 times 8 times 7 times 6. Is that a
Yep.
9 or? Okay,
Yep.
just making sure. I didn't know. I don't know. I don't just know what that was.
Yeah, I understand. You're just taking shots at my handwriting. Okay. Duly noted. See what happens if final grades come out. It's all good. So let's see. But yeah, so I'm glad you mentioned that. I didn't want anybody else to think that was a 41. That's 4 factorial. But yeah. Anybody else before we get into the next one? Make sure we're good. So in 2015, 18 horses were entered into the Kentucky Derby. How many different finishes of first through fourth place were possible? Once again, see that we have our ranking introduced into the problem. So that means we're going to use permutations. Permutations because the order matters. Order matters. We have 18 horses all together, choosing 4 out of the 18. Are we done with this red up
I
here?
was wondering,
Yeah.
from the last problem, how did you get all those numbers? Because I understand how you did the 10, you did 10 minus 6, you got 10 over 4, but how did you get all those rest of those numbers? I was wondering.
Yeah, so whenever you have the exclamation point in mathematics, that means you count down all the way down to 1. So same thing as if I have 4 factorial. That's going to be 4, 3, 2, 1. And so that exclamation point right here prompts me to do this part right here.
Okay, so
Makes you count
10,
that.
1, 2, 3, 4, 5, 6, 7, 8. So it's just 7, right? So how come you just didn't go all the way to 1 then?
Oh, because
All the way.
this 4 factorial down here is 4, 3, 2, 1.
Oh,
Yeah, and that's going to cancel out right here.
okay, now I understand, because you stopped at 4 because the 4 is on the bottom,
Yeah.
right?
Yep.
Okay, I understand now. I see it.
All right, cool. All right. All right, and always make sure you guys get clarity. Don't have me just rush through these problems, and you have questions. So always feel free to ask whatever questions you guys have. All right. So we have these 18 horses. We got first through fourth place. So we want to know how many different ways can these 18 horses come in first through fourth place. So N is 18, R is 4. Put it in your formula, unless you're throwing it in your calculator. 18 minus 4 is 14. And if you want, like I said, just follow this process with the 18 factorial over 14 factorial. Or you can put in the calculator like this. Or if you're putting the calculator from here, either way, you're going to get that 73,440. So, yep. either way, you're gonna have to lean on that calculator a little bit. Unless you're just nice with it, and you want to go 18 times 17 times 16 times 15. You know, by hand. You know, if you're nice with it, then it's all good. All right, question on the horse problem before we look at the next one.
Wait, hold on. I'm still writing.
All right, I ain't doing that. I'm good. You good? she probably, you must have anticipated me touching the thing.
I have a question. So I see that you did the 18, moved across. So then you did 18 minus 4. So what is underneath 18 over underneath 18? Is that
Right here,
19?
14.
Right. Oh, that's 14.
Yeah.
Okay. My bad. I didn't see it. I didn't know that was 14.
Telling you, man, I'm just taking notes,
I thought it
man.
was a 9. I thought it was a 9. 19. Oh, 19.
I have a question.
I'm listening.
Because you said for n is always going to be greater than the r. So, in like a word problem, to just find n and r, you just see which one's like the greater number. And
You can lean on that. R will never be greater than n.
Okay.
So that will never, because remember, you're taking R out of n. So it's impossible, you know, for you to take. In other words, if you flip this, if you have n being 4 and R being 18, it's impossible to take 18 out of 4. You know what I mean? So n will always be the greater number. Yep.
Okay. Thank you, big bro.
Not a problem, not a problem. All right. Let's look at that next one. So this one's a little bit different. Kind of leans back on what we were doing last section. And you see what I mean in a second. So we have 5 women, 4 men are to be seated in a row of 9 chairs. How many different seating arrangements are possible? Let's see, anybody lean on that red? Can I magnify it? You good? Okay. So A, if there are no restrictions on the seating arrangements. In other words, it doesn't matter where they sit. So we have 9 people all together. So each box here represents, you know, my 9 seats. So I'm going to, just like before, in each box, put down the number of options that I have. So if I have 9 people in that first box, I have 9 choices of people that could sit in that first box. Once somebody sit down, then I have 8 people to choose from. Then in the third box, I have 7 people to choose from. And then 6, 5, 4, 3, 2, 1. All right. So you have 9 seats. You can have 9 people to choose from initially on that first seat. Then in the second seat, after that first person sit down, that second seat, you have 8 people to choose from. Third seat, you have 7 people to choose from. 6 people, 5 people, 4 people, all the way down to there's only 1 person left. Once you establish that, you just multiply those numbers together. And that's 362,880. Make sure we are all right. All right, everybody okay before we go to B? All right, so the next one, we're exploring the idea that the women sit together and the men sit together. So I'm going to look at the women sitting first and then the men. So remember, there were 5 women. So I will look at those first 5 seats and just put the women there. That would be 5, 4, 3, 2, 1. And then in the next 4 seats would be the men. So that would be 4, 3, 2, 1. So I let the women sit first all together, and the men sit in the next 4 seats. Multiply those together, that gives you 2880. Then explore the idea that the men sit first and then the women. So the first four seats would be the men. So that's 4, 3, 2, 1. Then the women, 5, 4, 3, 2, 1. And we still should get the same number, 2880. It's just that we had to explore both options. First option, women sitting first, then the men. Second option, the men sitting first, and then the women. And then when you finish that, add those two numbers together. The actual answer is 5,760 different ways that they can be arranged in which the women sit together and the men sit together. All right. I scroll up.
How did you get the 2880?
What does that say after?
All right. Hold on. Ms. Regine, we had a question on the floor. I'm gonna get you in a second. You multiplied these numbers together. 5, 4, 3, 2, 1, 4, 3, 2, 1. Wait, yeah, 4, 3, 2, 1. And that's how you get the 2880. All right. I think that was Mr. Penner that asked that. But yeah, you just multiply these numbers together. You multiply these numbers together. So you get 2880 both times. All right, Regine, Miss Regine, what you ask? Hello?
Does this is
Okay.
the answer the one that you boxed in with the answer and then the does that say answer with the circle with the purple?
Right there?
Is that
Yeah,
Okay, just making sure.
No, you're fine. Yeah, I just want to make sure that, we saw that was the actual answer. We did our calculation, got 2880, and here we got 2880 as well. So we add those two numbers together, and our actual answer is that 5760. All right. Pretty good. Before we look at our last thing, we'll be done with it.
There's this thing that says combinations after the answer. Well, can I see that? I didn't finish it.
Are you talking about below?
Yeah, below.
Okay, so is everybody done with the red? Because that's where we're going.
Oh, all right. Okay.
Oh, no, you're fine.
I do have a question.
I'm listening.
Why did you multiply the factorials instead of just adding them?
That goes back to our fundamental counting principle. Remember when we had the clothes, the 30 pairs, 20, and the 10? Once you set up your options in each one of your categories, you always multiply them together. All right. So each one of these represent the options that we have for each one of our seats. Once you set up your options, you go ahead and multiply those together, and that will give us, these numbers right here. All right. Hope that answered your question. All right, so combinations, a collection of objects which the order does not matter. Remember, permutations, the order did matter. Combination, the order does not matter. Then we have our formula, combination of n things taken r at a time. Have that right here. Only thing's different is that you have this little r right here that permutations didn't have. So I'll give you guys a chance to write that down.
What does it say after the word two? Like combination of n things two, and then that word right.
That's taken.
Oh,
That's all right. Y'all keep talking about me. It's all good. Yeah. Combination of n things taking r at a time.
What does that say after and? Is that what is that?
All right. And where are we? You said
On
and.
the next question, on the next
You down here. You
yeah.
down here. Okay.
Yes.
All right. Everybody good? Can I scroll up? Everybody good? Okay. An emergency room at a hospital has 11 nurses.
Okay. I'll send it to you.
You gonna send it to me?
Bye. For this year. For this year. For this year. For this year.
I'm gonna go ahead and mute it. Okay, she good. Okay, she muted. So an emergency room at a hospital has 11 nurses on staff. Each night, a team of 5 nurses is on duty. In how many different ways can the team of 5 nurses be chosen? So notice how this problem doesn't mention anything about first, second, third place, no type of ranking or anything at all. So this will be a combination problem. The order does not matter. We just have 11 nurses and we want to create a team of 5 out of that 11. So we use the combination formula. So remember, n is always your larger number. So n is 11, r is 5, taking 5 out of the 11. So it's going to be 11 factorial over 11 minus 5 factorial times 5 factorial. Leaning on this formula right here. So throw that in the calculator and be careful here if you decide to do it that way, that you make sure you put parentheses over the 6 factorial, 5 factorial, so they can stay in your denominator. But your answer should be 462. So it's 462 different ways that a team of 5 can be created from the 11 nurses. All right. Pretty good.
can you go back up a little bit?
Mm-hmm. And once again, make sure you're efficient with using your calculator. I would lean on trying to start here and just go to the final answer versus, this extra stuff, since, I'm not holding you responsible for the process. But, yep, combination should be in your scientific calculator somewhere, just like permutation. Free calculators all over the place and apps and all that good stuff like that. If you go to the app store, scientific calculators, some free ones that will knock it out for you. All right. Got one more, and then we'll be done for the day. All right. Can I scroll up? Good. Let me know if I'm not. All right. So I believe this is the last one. A committee of 5 is chosen from 5 mathematicians and 6 economists. How many different committees are possible if the committee must include 2 mathematicians and 3 economists? All right, anybody holding on to the red? Okay, so talking about this problem, notice we want a committee of 5, but 2 of them have to come out of the mathematicians and 3 of them have to come out of the economist. All right, so now those 2 that are coming from the mathematician cannot come from the 6 economists. So I'll make sure we see that. So when I set up my combinations formula, that's going to be 2 out of that 5. So there's 5C2. And then this 3 economists can only come from this 6 right here. So that's 6C3. All right. So make sure we're okay. Why we did 5C2 here, 6C3 here. Once again, we want our committee to have 2 mathematicians. Those 2 mathematicians come from this 5 right here. And then those 3 economists that we want can only come from this 6 right here. So throw that in the calculator. 5C2 will give you 10. 6C3 will give you 20. Multiply those 2 numbers together, and that will give you 200. So it's 200 different ways you can create a committee with the 5 mathematicians and 6 economists.
Excuse me, Professor.
Yep.
I thought 6 times 3 was 18.
All right, so now that's not 6 times 3. Remember, that's your formula. So I'm gonna let me see if I can just minimize it for those who are copying. Remember that C is the formula of combination. So you're really setting up this right here. So you're right, 6 times 3 is 18, but you're actually putting that into a formula. When you see that C right there, that's the combination formula. And so you're doing 6 factorial over 6 minus 3 factorial times 3 factorial.
That's how you got the 20.
Yep. And so I don't know if anybody's still copying those words. So if you go through the process, I did that right here because somebody else had asked about the process. So if you're talking about walking through the process, let me erase this stuff. I went ahead and I'm going to cancel out this 3 factorial and I expanded out this one. So I took the 6 down to 3 factorial, and we talked about that evaluating process, so that this 3 factorial will cancel out with this 3 factorial. And then also 3 times 2 is 6. So they cancel out. And that leaves me with 4 times 5, which is this 20.
Okay, I see now.
Yeah. So, yep, not a problem. So once again, this process, if you want to learn it and you need help with, fine tuning it, I'm most definitely willing to help. But this process, you don't necessarily have to lean on as long as you know how to use your calculator. And if you have any questions about that, I can help you with that as well. All right. Questions before we look to close out today.
Professor?
Yep.
I'm gonna, once everyone hangs up, if I could have at least 50 seconds of your time.
Yep, not a problem.
Thank you.
All right, anybody else before we close?
Oh, and just for you did for the 6C3, that's the same thing for 5C2, correct?
Yep.
Okay, then I'm good.
All right.
I'm fine. I'm about to finish 12.3 right now.
Oh, okay, so you done with the class. You about ready to be. You want the final exam tomorrow? I mean, I got it for you. You ready? So yeah. Not a problem. So with that being said, we're done for today. Next class we'll look at 12.3. Try the stuff out. See if you have any questions or concerns. There'll always be room for those questions if you have them, or shoot me that email if we need to meet outside of class for a Zoom session. Then most definitely we can do that. Other than that, you guys have a great one. Y'all be safe, And
You
I
too.
will see you on.
Thank you.
Thank you.
See
Thank you.
you.
Thank you. I'll see you on Thursday. Y'all take care.
You have a great day.
You do the same.
I have a question for the homework.
Uh-huh.
Okay. Hold on, let me turn my thingy around.